Okay, so for numbers 11 through 16, we have logarithmic equations. For the first four, numbers 11 through 14, we have log equals log, and for 15 and 16, we have log equals number. So for log equals log, what you're going to do is you need to condense the logarithms first on both sides of the equation. Once you have them both condensed, you can take what's inside of your parentheses, set them equal to each other, and then solve for your variable. So we're going to, on the test and on these, all of the log equals logs are already condensed. So you don't have to worry about that step. You can just go straight to setting what's inside of your parentheses equal to each other and then solving for your variable. So for number 11, we have log base 13 of 9x minus, or 9 minus 3x is equal to log base 13 of negative 5x minus 5. Well, you have to, so what we're going to do is we're going to set this equal to this so that we can figure out what x is. So 9 minus 3x is equal to negative 5x minus 5. And then we're going to solve for x. So I'm going to add 5x to both sides. Get rid of it here. And I'm going to subtract 9 from both sides. So negative 3x plus 5x is 2x. And negative 5 minus 9 is negative 14. Now the final step to solve for x, divide both sides by 2. And you get x is equal to negative 7. Answer D. So on the test, just like this one, all of them are already going to be condensed. So when you get to the log equals log problems, all you have to do is set your terms inside of the parentheses equal to each other and solve for x. So we're going to do that same thing again here for number 12. So we have log base 19 of negative 5a minus 3 is equal to log base 19 of negative a plus 9. They're already condensed. So all we have to do is set both of these equal to each other. So negative 5a minus 3 is equal to negative a plus 9. So now we're going to solve for a. I always want to keep my variable positive, so I'm going to add 5a to both sides to keep a positive. And I'm going to subtract 9 from both sides. Now what we get here, negative 3 minus 9 is negative 12. And then I have negative a plus 5a, and that's going to be positive 4a. So I want to know what a equals, so I'm going to divide both sides by 4. And I get negative 3 is equal to a, or a is equal to negative 3, which is option C. So number 12 would be C. For number 13, we have x squared, so that means that we're going to have two solutions, right? So already condensed, so all I have to do is set these equal to each other. So I have x squared plus 18 is equal to negative 9x minus 2. Since we have two solutions, the easiest way to solve is to factor. And when you're factoring, you want to make sure that everything is on one side of the equation and the other side of the equation is 0. So I'm going to move all of these terms over to this side of the equation. So I'm going to add 9x to both sides, and I'm going to add 2 to both sides. So we get x squared plus 9x, and then we have 18 plus 2, which is 20. So x squared plus 9x is equal, or x squared plus 9x plus 20 is equal to 0. And now when we're factoring, what we're going to do is we're going to think of two numbers that add up to 9 and multiply to 20. So if you don't know how to do this, you're going to look at the factors of 20. So 20 is divisible by 2, 2 times 10, but 2 plus 10 does not equal 9, so it's not those numbers. 20 is not evenly divisible by 2, or sorry, by 3. It's evenly divisible by 4, that's 4 times 5. 4 times 5 gives us 20. 4 plus 5 is 9, right? So those are their two numbers, 4 and 5. So x plus 4, x plus 5. And then to solve, what we're going to do is we're going to set both of these terms equal to 0. X plus 4 is equal to 0. Subtract 4 from both sides. And you get x is equal to negative 4. Here, x plus 5 equals 0. Subtract 5 from both sides. The x equals negative 5. So those are your two solutions right here, which is option C. On the test, you will not have to solve for extraneous solutions. You can just go ahead and solve your problems. Whatever answers you get is what's going to be your answers on the test. So yeah, you don't have to worry about extraneous solutions. Normally, you would plug in your solutions into your original equations, make sure that they both work, but you don't need to worry about extraneous solutions on the test. So whatever you get, just select that as your answer. All right, number 14 is our last example of log equals log. So we're going to set these terms equal to each other. So we have negative 24 plus 2n squared is equal to 3n squared plus 10n. Let me write it smaller. I'm just going to write it over here. Negative 24 plus 2n squared is equal to 3n squared plus 10n. So again, we want to get everything on one side of the equation, and I want to keep my leading coefficient positive, so I'm going to subtract 2n squared from both sides. That keeps my n squared positive. I'm going to add 24 to both sides. And we get 0 is equal to 3n squared minus 2n squared is just n squared. Then I have plus 10n, and then I have plus 24. So now I want to think of two numbers that add up to 10 and multiply to 24. So those two numbers are going to be 6 and 4. X plus 6 times x plus 4. 6 plus 4 is 10, and 6 times 4 is 24. So those two numbers work. Is equal to 0. And then you set both of them equal to 0, and you get, so you have x plus 6 equals 0. Subtract 6 from both sides. You get x equals negative 6. X plus 4 equals 0. You subtract 4 from both sides, and you get x equals negative 4. So the answer for number 14 is B.